So last full talk of the day, the panel's coming up after this. So my name's Baldur Karlsson. I'm going to be talking about RenderDoc and sort of how it got started, the story of how it came to be where it is today. For those of you who aren't familiar with it, RenderDoc is a sort of single frame capture debugger. So you capture a frame out of your application, and then you can load it up in an analysis program afterwards. So a little bit about me and where I started. I was a graphics programmer at Crytek, and I joined in late 2010. So when I started, I was working on Crysis 2, and we shipped that in early 2011. And sort of when I was working on that, it was on PC and consoles. It was a simultaneous release. And for consoles, in this context, I mean Xbox 360 and PS3, that generation. So after that, I worked on the port of the first Crysis game to consoles, again PS3 and Xbox 360. So I was working only on the consoles. There wasn't really a PC version for that because it had already shipped several years before. So I was working only with the console graphics tools. When I shipped that project and I joined Crysis 3 at the end of 2011, I was then back into the PC world, and the graphics tools kind of compared badly. It wasn't a very sort of pleasant transition. So for those of you who haven't played it, this is Crysis 3. It's a sort of complex graphical game. There's a lot to the renderer, and so that means a lot of rendering bugs. So PC graphics tools, like I said, they were a particular pain point. And the workflow I ended up with was whenever I would get a bug, the first thing I would try and do is reproduce it on the consoles. If I could get the bug to happen on 360 or PS3, then I was able to use those tools and I could just verify my fix worked on the PC. If it was a PC exclusive bug just because of the vagaries of the platform or because it was a bug in some PC only graphics technique, then oftentimes the tools wouldn't really work and I'd be reduced to printf debugging. Everyone's kind of done this. You edit your shader so it outputs a particular color and you try and diagnose what's going wrong based on red or green appearing on the screen. It's not very sort of a good workflow. So in 2012 we're talking about D311 debuggers, and we had sort of what people are familiar with, a similar sort of situation you have today. Each of the IHVs have their own tool, and then at the time Microsoft had two offerings. There was the older PICs, and this was the original PICs for Windows, not the new PICs for Windows, and then it had the Visual Studio graphics debuggers. But they kind of didn't work very well. They were kind of unreliable. They crashed a lot. They would, sort of take a long time to, work with, with the complexity of Crysis 3. And they may lie. They may produce incorrect results. They may have some kind of bug internally that caused them to not fully represent what was being captured. So I wondered, sort of what would it take to write a graphics debugger? Sort of what at its core does a graphics debugger do? And the main thing that it allows you to do is inspect what is happening midway through a frame. It allows you to take apart the frame and see the intermediate results that are being generated and then used and consumed and thrown away to get to the final frame result. And in order to do that, what you need is a concrete representation of the frame. You need to be able to pick it apart and see what the inputs are at any given point. You want to see what the pipeline state is, and you need to be able to go back and forth through the frame. You can't really step through it in one direction because you're always going to be looking back and forth at dependencies. So what did I do? Of course, I can just write my own graphics debugger. That's not going to be a problem at all. So I kind of came up with a naive plan. And the idea is that I intercept all of the graphics commands that are recorded for the frame, and then when I want to analyze them, I replay all those frames and then just, all those commands, and then just kind of stop. Wherever I want to look at something in the middle of the frame, I replay everything up to that point, and then I can sort of display what the texture contents are at that point in time. I can read back the pipeline state, I can inspect contents, and the API actually gives you some pretty good guarantees. If you go and read the Vulkan spec, and I recommend that you do, you'll see that there are a lot of guarantees about what things are allowed to vary and what things cannot vary, given identical inputs and identical commands. And it's not 100%, but it's pretty close. So this is the point where I tell you that plan is way too simple. A graphics debugger is a lot more complicated than that, and it never would have worked. But that's not actually the case. This is pretty much how RenderDoc works today and across all of the APIs that it supports. It's obviously a simplified view. It's not, covering everything. There are a lot of details to be worked out sort of within the implementation of that, but it's also not inaccurate. There's nothing in there that sort of doesn't actually represent reality. And so the first commit that I made, according to the repository I have, was in June 2012. And that's when I started working just in the sort of spare time that I had, trying to sort of build up something. And about a week later, I had the very simple basics. I was able to intercept all of the function calls, and this is D311, and they were able to just serialize out to a text file all the parameters and the structures within there. And you can see that I'm just serializing out pointer values here. This is direct sort of just dumping to disk of everything that was actually called. And then a couple of weeks after that, I had a very core kernel of a proof of concept. I had a sort of visualizer of the UI. And sort of on the left here, that's just the raw pointer value of whatever texture I want to display. So this happens to be a render target, but I could also select a static texture or whatever I actually wanted to display sort of in my debugger. And then the right here, this is just the index of the function call in the frame. So it just so happened that in this frame, the 55th function call was a draw call, and that's where I was able to select where I wanted to be in the frame. And so the core loop, as I described before, it would just replay from 1 up to 55, and then it wouldn't do anything after 55. And this is the contents of that particular texture at that point in time. So I didn't have very high expectations for this. I was trying to create a graphics debugger that I could use to solve my problems. I was very selfish. And because other people in the office were working on the same kind of games, they were going to be running into the same kind of problems, it's reasonably likely that they're going to use the tool as well and find some use out of it. But I didn't have any grand plans. There was no sort of vision of the future. I was just sort of solving my own problem here. So I iterated further, and I added sort of the event browser on the left here, where you can actually sort of see where the draw calls are. I sort of started to expand out the texture viewer and add a few more inputs for sort of visualization options. And because I didn't have sort of this large grand plan of where I was going to go, I could iterate fairly simply. Sort of at any point when I wanted to I encountered an HDR texture and I needed to be able to see outside of the linear 0 to 1 range. I wanted to zoom in on a sort of a smaller part of the texture, or sort of zoom out to see sort of 0 to 100, then I was able to implement that. And I kind of credit this for keeping me motivated. So if I had sort of a long sort of years plan, and I realized that, okay, now I need to do a bunch of boring stuff to lay the foundations for some tool that I'm going to create in the future, I would have gotten bored and dropped the project, because this is just a hobby. I was just kind of doing it for fun. So because I was able to jump around between different aspects and just sort of work on what I wanted to work on any given day and just solve an interesting problem, I was able to keep working on it. So I iterated further, and you can see there's a bit more polish happened here. And it's a little simplistic, but this now has this sort of docking UI. So instead of being just a fixed UI that you can't customize, you can now choose anywhere you want to place the texture viewer on that view. And then I added the pipeline state. And this is a very tedious thing to add, because there's a lot of information in any given pipeline state. But it's critical to be able to see what bindings are active, what sort of rasterizer state you have set up, and everything like that. Then I was able to add the geometry viewer, so I could see the raw sort of numerical values that are input and output from the geometry stages, as well as a 3D rendered preview to see what the object actually looked like. And if you stop at this point, you realize that 90% of what you actually use, sort of 90% of the time, you're using this core toolkit. You want to see what the contents of textures are, or buffers. You want to see what constants are, what the pipeline state is. You want to inspect the geometry, and you want to be able to do that while stepping through the frame. There's a lot more that you can add to a debugger, and at this point there's a lot more polish that it requires, but it's still sort of the core toolkit that you're going to use most of the time. And so at this point I knew that I was able to implement the graphics debugger to solve my problem. It was going to take a lot more work and a lot more bug fixing, but this was kind of the proof of concept. So I tagged the Alpha 1 build. This was the 27th of May 2013. So it was too late for Crysis 3. We'd already shipped it, so I wasn't able to use this to solve any of the bugs that I had on Crysis 3. But for that game, we had dropped D3.9 support. So on PC, we were only using D3.11, so all future projects were going to benefit from having a debugger available. And this was the first time that it was able to actually mostly capture CryEngine. So I was able to bring it into work and sort of actually use the tool day to day and sort of solve my problem. So finally, the savior has arrived. We now have an actual reliable tool on PC, and well, so it wasn't quite working perfectly. It was crashing regularly. There was a lot of corrupted replay output. It was lacking features, and it wasn't production ready. So it seems like I've spent a year of my time getting back to square one where we were before. But the advantage is now it's a homegrown tool. So I have the source code. I understand exactly how the tool is made. So I can fix a bug in minutes or a couple of days, rather than having to generate a repro case, send it off to a vendor where they can fix it, and hope that they're able to also reproduce it and then fix it and then get it back to me in the next version, which could take sort of months to come around to me. I was able to sort of fix anything I ran into directly, sort of because I had that understanding. And obviously at the time this is a very biased view because I was the only one with the source code and I was the only one able to fix bugs. But the principle of it is that it's a highly tailored experience. So within the office, we were able to request features. So someone said, okay, we have a packed gbuffer. It's sort of encoded in an obscure way. I'd like to be able to write a custom shader to visualize that again, so I can actually see what the diffuse color is or what the specular sort of component is, or whatever we had at the time. And so I was able to implement those feature requests directly. And it was a very quick turnaround time. And I realized that, so this was a good thing for us, and it could be a good thing for other people. So I had no idea of how well it would be received, if other people would trust a tool that had just been written by some random guy at Crytek. But I thought there was nothing to lose by releasing it publicly. Sort of it could go out there, and if even only a couple of people actually make use of the tool, then it's no skin off my nose. It's kind of benefited them, and it hasn't taken away from the experience for me. So I kind of set myself the goal that by September of that year, I would have a build that was polished and stable enough that I could actually sort of ship that to people and be confident that that was a good release. And so I had a build ready by September, but unfortunately there were some internal delays that meant that it didn't get released immediately. But fortunately, Valve had this event called the Steam Dev Days in February of 2014, and they released their OpenGL debugger, Vulkan. And this was kind of the kick in the pants that was needed to get the process rolling, and so later that month, RenderDoc did get released to the public. And it was initially only a binary release, but about a month later, after sort of legal hurdles had been completed, we were able to release the source code in March. So this was the first public release, and this is version 0.18. That's kind of what it looked like. You can see that a lot more polish has gone on since the earlier prototypes, but fundamentally it's still the same tool under the hood. It's got all the same core toolkit. And the version 0.18 that actually follows on the numbering scheme. So Alpha 1 to 12 were the internal builds that were only shared privately amongst the office. Once I realized that I was approaching a public release, I sort of switched to a more public versioning number. So 0.13 to 0.17 were sort of release candidates, if you like, or private builds that went on sort of before the public release. And then 0.18 came out. And at the time, this is Windows only and DX11 only. So like I said, this has been focused mostly on solving my problem, and at the time my problem was debugging DX11 programs on Windows. So I left Crytek in the end of 2014, and because I had been working on it just in my spare time, it had never been something I'd worked on sort of as my job at Crytek. It was very natural to continue working on it in my spare time after I'd left. So I continued improving it, adding features, and I sort of worked on, there was a long list of features that would be useful and features that I found interesting to work on. And sort of I balanced sort of the feedback that I was getting from other users against sort of what I thought would be most useful to add to the tool, as well as, like I said before, what was kind of fun and interesting to work on because I wanted to keep my motivation up. So OpenGL support was released about a year after the first public release in February of 2015. And as it is today, this is support for modern OpenGL. So it's the core profile, versions 3.2 to 4.5, plus a few sort of ARB extensions. And this is still Windows only primarily. So there was technically Linux support in there. At its core, there wasn't that much code that was actually specific to Windows or Linux in terms of OpenGL. But the main blocker was that the UI was written in .NET. And this wasn't going to port easily over to Linux, so it was only kind of headless Linux support. So you were able to capture from the command line and sort of capture your program, but then the frame that you got, you would still have to load up on a Windows PC on the Windows UI. So it wasn't perfect. And then, sort of more interesting to people in this room, Vulcan support. So I was approached by LunarG at SIGGRAPH at the end of 2015, and they were preparing for the Vulkan 1.0 release. And their motivation was they wanted to have a graphics debugger available at the same time the spec was released. So they wanted people to be able to go away, build their Vulkan 1.0 applications, and be able to debug them immediately, rather than having no tools to work with that release. Now, at the time I was working at Unity, and I realized that sort of turning around API support within a few months wasn't going to happen. I was just working on this on the weekends. So with support from Unity, I was able to dedicate part of my time there to implementing Vulcan support, and this was released again, just sort of starting to become a tradition, on February of 2016. At the same time as the 1.0 spec went out, there was a new release of RenderDoc. It was included in the Vulkan SDK, and everyone was able to debug their Vulkan applications sort of when it came out. So then the next logical step after that was Linux support. Like I mentioned, it had been sort of headlessly supported in older versions, but there wasn't a UI, and that was a real problem. So the only practical solution to that was to have a Qt UI that would then be able to run across platform, and it did require a UI rewrite. So it did take quite a while. So in February of 2017, I then released the Qt UI to Linux only. And sort of a few months ago when I released 1.0 of RenderDoc, the Qt UI was then rolled out across platforms. So it's now the only UI that exists. And on Windows and Linux and any other platform, you run the Qt UI. So it makes it a lot less of a maintenance burden rather than having to support two UIs, make the same bug fixes in both places and everything. It would have been a nightmare. So that kind of brings us up to the present. I've now been working on RenderDoc for sort of past 2 years, and I've been contracting full-time with Valve. And it's used by sort of many companies. I've been contacted by a lot of people sort of within and without the games industry. It seems to be sort of getting quite a lot of support. And according to the analytics and telemetry I added in 1.0, there's roughly about 1,000 people using it each month. And if you compare sort of to where it started, or at least sort of compared to the first sort of source release publicly, it's been just over 7,000 commits and about 295,000 lines of code. So it's been sort of quite a journey in sort of building up, but it's always been in sort of small increments. It's been sort of adding the next new thing, the next new feature. There's never been any grand change since that core prototype that I showed you before. And RenderDoc 1.0 supports Windows, Linux, and Android, and you can use Vulkan, D3.11 and 12, and OpenGL and OpenGLS. So looking into the future, I continue to plan to support it and sort of add new features. I seem to have a to-do list that only grows in size rather than getting smaller, which seems the wrong direction, but that's how it's going. I'm going to be working on this for many years, I hope. And sort of, if you look at the latest GitHub code, it now supports Vulkan 1.1. And there have been contributions from sort of AMD, Samsung, Google, and Imagination. They're all sort of bringing in their additions into the project. And I hope that that continues as well, sort of to improve the project and sort of bring it up even further. But that's basically the story. So does anyone have any questions? Yes?
What was the hardest API to add support for?
The hardest API to support. If you consider maintenance over time, definitely OpenGL. Just because of the number of quirks and corner cases and weird things in the spec that are technically legal and so I technically have to support. In terms of actually adding it, probably OpenGL as well, honestly, because D3.11 had a lot of other things happen at the same time. It's kind of hard to measure. Vulkan was a very easy API. Vulkan is the easiest API to support, certainly, and D3.12 I was able to draw on a lot of the things I had done for Vulkan. So yeah, OpenGL on both counts, I think.
Yeah. Think about going to the Mac.
Mac support. I wouldn't rule it out. The main thing is that I only have a finite amount of time, and so I need to prioritize what's going to be most useful, what's going to be sort of used by the most people, trying to make some kind of value judgment of what's most important to work on now. So while I might do Mac support in future, or maybe someone else would do Mac support, sort of sooner, I wouldn't rule it out, but it's not going to be on my immediate to-do list now. Yes?
What is the minimum Android version?
Sorry?
What is the minimum Android version?
Android version requirements. So I believe the latest GitHub code works on Android 6. So this was something that I hadn't really I wasn't too familiar with Android when I started in the project. So I think the 1.0 release that added Android support only works on 7, because there's some command that some ADB command I was running was only added in Android 7. But if you look at the latest GitHub code, as far as I know, that works on Android 6. So if it doesn't work for you, then file a bug. I'm unlikely to go further back, because I believe it then becomes more and more difficult to support. But I'm open to it if it's sort of contributed anyway. Okay, I think we're done. Alon for the panel.